All right, here we go. So today we have done parts 1 and 2 before when we did exponents. So these parts are review. We're going to learn. We've kind of done this, but we're going to learn how to do it. And then this is the new thing, conjugates. It's exciting. So today we're going to be able to simplify a radical expression in any form, which means we're going to use perfect squares. So please write, we will use perfect squares. Or use perfect squares.
Can I just draw a square with like a halo?
No.
That's a perfect square.
That's an angelic square. Those are two different things. Boom, knowledge. Alright, so what is the first perfect square? And then? We made a note card on this, right? You guys have that note card?
Maybe.
I would get that note card out.
I had it the day that said
It is. It's 1, 4, 9, 16, 25. What comes after 25? And then?
49, 55.
What is 8 times 8?
64.
Okay, so what's the square root of 1? What's the square root of 4? What's the square root of 9? Square root of 16? Square root of 25? Square root of 36? Square root of 49? Square root of 64? Square root of 81? Square root of 100? Alright, then we have 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. You'll probably still need this, just to let you know. Alright, what's 11 squared? 12 squared. 13 squared. 14 squared. 15 squared. 15, 6, next one. That guy. What's he squared? 17 squared. 289. 18 squared is 324. Somebody do it and make sure I'm right. 324? And then I know 19 squared is 361, but make sure I'm right. And what's 20 squared?
4 honey.
All right, 4 honey? No, it's not 4 honey.
I said 4 honey.
It's not that either. All right, so what we're going to be doing is we're going to use our orange columns, our perfect square. And remember, you find the biggest perfect square that goes into the number and separate it. We have done this before. The reason we use perfect squares is because our index is 2. Remember this number in the mullet? Do you guys remember us doing this? Is anybody alive out there? Curtis?
Kurt.
Are you for real?
Yes.
This boy got me.
Okay. Now, I can't even talk to you right now. What is the biggest perfect square that goes into 80? Now remember, that's our orange list, so don't you dare say 8 because that's not a perfect square. 16? 16 times what? Alright, so we break it down into 16 and 5. You should be writing. Alright, and what is the square root of 16? So 4 comes to the outside of the radical, and what does 5 do? Stays inside. Does anybody remember us doing this? Woo! Awesome! And boom, we're done. Because 16 is the biggest perfect square that goes into 80. We divided. We used our knowledge. Square root of 16 is 4. So you go right here. And this is the square root of 16 is 4. So when you're using perfect squares, it's 2 numbers that multiply by itself to get that number. So this breaks down into 4 and 4. You have 2 of them, so 1 comes to the outside. Anybody else have any questions? Alright, let's look at B as in potato. What is the biggest perfect square that goes into 180? 36 times what? If you don't know how to do that, you take your calculator and you divide. It's not magic. It's not witchcraft. It's not sorcery. You just divide. It's mathematics. All right, what's the square root of 36? So what comes to the outside of the radical? What stays in the house? Fantastic. 6 root 5 is how we say that. How do we say that?
6 root 5.
Woo, it's like we learned something.
Sorry.
All right, we're ready for the next step. C. What are we going to do with those?
Multiply.
You're going to multiply them.
Got you.
All right, what's 2 times 14?
Oh, yeah.
Okay, now we need to simplify that. What is the biggest perfect square that goes, it's like a, never mind, I'm not going to show my dorkiness. What is the biggest perfect square that goes into 28?
4.
4. And 4 times what gives you 28? 2 times 14 is 28. So when you have these under the radical, you can multiply them together. If there was a number on the outside, say it was a 3 here and a 6 here, you would do 3 times 6 and you would get 18. Can everybody just go ahead and add that since I've added it to mine? Everybody add the 3 out front here, the 6 out front here. Man, you're fine. That's going back old school. Like college. Sorry. Anyway, I digress. All right, now what's this? what's the square root of 4?
2.
All right, now what are we going to do with that 2 and this 18?
Multiply.
We're going to multiply them together. You're going to do 2 times. I'm zooming in for you, Miriam. I know you can't see.
Like, I for real cannot.
I need you to for real go to the eye doctor.
I will.
And you do get 36. And what stays under the radical? Okay, now let's walk through that problem one more time in case we're confused in between the singing and the yelling. The first thing we did was 2 times 14, and we got 28. And then we added the 3 and 6 just so we could see what would happen if we had a number on the outside. You would also multiply those together. Now, the radical is a barrier. You cannot multiply what's on the outside with what's on the inside. You can't do it. All right, then we broke 28 down into 4 and 7. We took the square root of 4 and got 2. And then we did 2 times 18 and got 36, and 7 stayed in the house. Does anybody have any questions? Yes.
How much did you 18?
We did 3 times 6. This 3 times this 6 gave us 18. Two times 14 gave us 28 because it's under the radical. The square root of 4 is 2. 2 times 18 is 36. Yes. What was your question? Okay, you're fine. All right. Does anybody have any questions on part 1? You are going to have homework tonight that is going to help you review part 1. Are we ready for part 2? Part 2 says simplify with variables. Okay. You remember this? Hallelujah. All right. Now, who remembers what number is in the mullet when it's just a square root?
1.
2. There's a baby 2 there because it's called square root. It is a baby 2. So that is going to come into play once we get to the variables. Now, first, what's the biggest perfect square that goes into 90?
30.
30 is not a perfect square. What's the biggest perfect square that goes into 90? 9. 9 times what? Okay, we're going to leave this here. Now, what's the square root of 9?
3.
So we're going to have 3. And we're going to leave some space so that we can write our variables because they're going to have to come to the outside, and we're going to write our radical. Now, what stays under the radical? The 10 stays under. Does everybody see where we got 3 and 10 from? Before we go any further. Does anybody not see? Speak now or forever hold your peace. Square root of 9 is 3. Right here? Because 9 is the biggest perfect square that goes into 90. The number right here? What are you talking about?
Over here. On the, no card.
Over here?
Oh, you're up there. Okay. I was at the bottom.
Are you with me now? Okay. Alright, now let's look at our radicals. Now remember, this is a little baby 2. I'm sorry, our variables. That's a baby 2. And when we have variables, we divide. We say 2 goes out into 3 how many times? Once, with how many left over? Does everybody understand? Are we sure? Alright, 2 goes into 4 how many times? 2, so it's y squared. Do we have any left over?
No.
Nope, I should have left more space. Alright, are we ready for the next one?
Yep.
2 goes into 5 how many times?
Twice.
Twice, with how many left over?
So 0. That's the
So on the outside, it's 3x y squared z squared under the radical 10xz. Does anybody have any questions? Do we need to walk through that one more time?
Yes, please.
Okay. Now, do we need to walk through the numbers one more time or just the variables?
The variables.
Okay, variables. Does anybody need the numbers? All right. We said that 2 goes into 3 once with 1 left. I'm explaining it. You're not looking at the board.
So I was-
We said 2 goes into 3 once with 1 left over. So that's why we have 1x here and 1x under the radical. Then we said 2 goes into 4 twice with none left over. So that's why we have y squared. Then we have 2 goes into 5 twice with 1 left over. If you don't know how to divide, or if that confuses you, you have 3 x's. You need one set of 2 and there's 1 left over. So that's why we have x root x. We have 4 y's. We need sets of 2 because of this 2 right here. We have 2 sets of 2, so that's why it's y squared. Does everybody understand so far? How many z's do we have? 1, 2, 3, 4, 5. We need sets of 2. We have 1, 2 sets of 2 with how many left over? And that's why he goes under the house. We have. But remember, I don't know if you were here yesterday, or maybe it was the day before, when I said, do you guys remember this from last week? And everybody stared at me like I had antenna growing out of my head. So, alright, ready for B? Does anybody have any questions on A? Alright, let's look at B. B is in potato.
8,
4. 8 and 4.
I think there's a bigger perfect square that goes into 32. It's 16.
Big thing.
Okay, now what's the square root of 16?
8. 8. I mean,
Y'all, look at 16. What's the square root of 16? It's 4.
I'm sorry.
Y'all need to make your note card again.
Come on, bruh.
Alright, now, are we ready for the variables? Let's leave some space
The 2 is up.
and go ahead and put 2 on the inside. Now, why does 2 stay under the house?
It's,
Because it's the,
I'm just trying to multiply them.
Kind of, but it's because there's one of these. He wants to stay inside and read Harry Potter. The 2 people want to go out and play. The 1 person wants to stay inside and read Harry Potter. That's why it's sets of 2. Does everybody understand? Alright, now let's look at our R's. Remember, this is a baby 2. 2 goes into 2 how many times?
1.
Does it have any left over? Alright, so that's why we have an R there. 2 goes into 4 how many times?
3 times.
And do we have any left over?
No.
So that's why it's K squared. Alright, 2 goes into 5 how many times?
Twice.
With how many left over?
1.
So it's 2t under the radical.
Why put that little line in there?
Because that tells me that the radical has ended. And I would highly, highly, highly suggest y'all start doing that. Remember on the work yesterday? right here, where some of y'all got confused and thought maybe that 2 was under the radical, it's not. If it doesn't cover it, it's not under the radical. The computer programs don't have a way to put that little hook at the end, so you should make the hook. And it's a habit from college classes and awesome math teachers that made me do things like that. All right, I want you to try C without me. See what you can do. Nathan, this is not your first day in here. It's May. Is that better? Does anybody need a note card to make a new perfect square note card?
I did.
Everybody.
Don't look like there's everybody in the room. Some people cut theirs.
I
Does
mean,
anybody need it laminated afterwards?
I do.
Justin does.
I do.
I'll laminate. I'll more or less do it.
David eats.
Oh.
Is it like a?
No, they're two different things. I do have the silhouette at home, which is a more user-friendly version. Anybody else need a note card?
Oh, never mind.
What about sticker? We need to make one sticker.
I bought my sister a button machine to make her own buttons, and I wish I had one. I would make a button for, like, my moods. Leave me alone today, children.
I like.
Or I'm happy today, bring me chocolate. Y'all don't know what 10 squared is? Or 20 squared?
Oh, can you go there?
No.
Oh my gosh.
You didn't know nothing.
Nobody's talking to you.
Hey, keep it going.
No. Alright, what's the biggest perfect square that goes into 56?
4 more to do.
8 7.
8 is not a perfect square.
Oh my god.
14 and 4?
Yeah.
Okay, thank you. Alright, so what's the square root of 4? 2. And 14 stays under here, right? Alright, does 2 go into 1? So what does this x do? It stays under the radical. No. Does 2 go into 10? How many times? And does 2 go into 5? How many times? 2 times with how many left over?
1.
Did anybody get that as their answer? Woo! Great job! No. Nope.
Please?
Nope.
I got some pretty designs.
Yes.
Nothing of this.
I have 4 more.
Alright, so the perfect square is the orange. The orange are my perfect squares. And the blues, right here, the blues are the square roots or counting numbers.
We write that too.
Yes. Not always. So, whatever number is not a perfect square, whatever number is left over, that's what goes in the radical. It's not always the bigger number. Here it was 2, and that's not bigger than 16, right? So it's what's not the perfect square. Does that make sense? Okay. Does anybody else have a question before we go any further? Yes.
I'm confused on
What's your name on the back?
you get the 2 numbers under the main number.
You divide. So you take your perfect squares and you divide them into 56 until you get a whole number. So you could start with 36. You would do 56 divided by 36, and that would not give you a whole number. And then work your way down. That's all you do is divide. Alright, does anybody need it laminated before I start on part 3?